Hello everyone. Let's move on to next question. Question is nothing but a line passing through the points 1, 0 and 4, 3 is perpendicular to the line joining -2, -1 and n, 0. Find the value of m. That means here they have given 4 points through which two line passes and we need to calculate the value of m for which two lines are perpendicular. Two lines are perpendicular. To solve this problem, first thing is we are in need of the equation of two lines. To obtain equation of two lines, we have one of the concepts which you are going to study in first PUC. But as if we need to solve this problem in 10th standard, so let us make use of area of triangle concept. Okay. First, let us construct a triangle. See here, if this is a triangle, ABC are the vertices of a triangle whose coordinates are x1, y1, x2, y2 and x3, y2. x3, y2. Whenever we know three coordinates of triangle, the area of triangle can be obtained with the help of formula 1/2 times of x1 into y2 minus y3 plus of x2 into y3 minus y1 plus of x3 into y1 minus y2. So this is the formula which helps us to calculate area of triangle. But here we are going to calculate an equation of a line. To calculate equation of a line, whatever the points we consider, those points should lie on same line. Here, since we are making use of area of triangle, if the point A lies on point B, then we can say that these 3 points lies on same line. Easily we can obtain equation of triangle. To say A lies on B, it is compulsory that area of triangle should be 0. That means by equating area of triangle to 0, we are going to obtain the equation of a line passing through 2 points. Okay? And even to make use of this concept, we are in need of 3 points coordinates. So first let us consider on point, let P of x, y be any point. Be any point on line. On line L. Okay. On line L1. What about this L1? L1 be a line. L1 is a line passes through 1, 0 and 4, 3. L1 be a line passes through the points 1, 0 and 4, 3. Now let us obtain the equation of line L1. Equation of line L1. Equation of line L1 is, as if we are going to obtain equation of line L1, so we are considering the formula that is nothing but area of triangle. We are equating this area of triangle to 0. If we equate area of triangle to 0, then what happens? See here, for meantime we can treat x1, y1 coordinates as x and y, x2, y2 coordinates as 1, 0, x3, y3 coordinates as 4, 3. I am going to substitute these values in this area of triangle by equating them to 0. That is nothing but area is considered as 0, then formula is nothing but 1/2 times of x1 in the sense x1, y1 is nothing but an x, that is x1 is x, y2 coordinate is nothing but 0, y3 is 3, that is 0 minus 3 plus of x2 is nothing but 1. Next we are in need of y3 minus y1, y3 value is 3 and y1 is 1, so it becomes 3 minus y plus of. Next x3 is required, x3 is nothing but 4, substitute those values over here, that is y1 minus y2 means y minus 0. By solving this equation, we will come across the equation of line L1. That is nothing but cross multiply 2 to 0, then we come across minus 3x plus 3 minus y plus 4y which is equal to 0. So it gives values as bring this 3x minus 3x to right side and even minus y plus 4y means it is plus 3y, shift this up to right side. Then this equation in simple form can be written as 3x plus 3y which is equal to 3x plus y which is equal to 1. Call this as equation 1. Equation 1 represent the line passing through the points 1, 0 and 4, 3. Similarly, with the help of same concept, by using same formulas, we are going to obtain the equation of line passing through the point -2, -1 and m, 0. That is, let once again I am considering these variables point as one of the vertex for line joining these 2 points also. That is nothing but p of x, y. Let p of x, y be any point on line L2. Why I am considering same point means I am going to obtain 2 line equation in variables x and y. That's it. Okay. Next, L2 is a line. L2 is a line passes through points. -2, -1 and m, 0. Again, to find this line equation, make use of same formula, that is nothing but equating area to 0. So, if we equate area to 0, what happens? 0, which is equal to 1/2 times of here. Once again, we can consider x1, y1 as x and y, and x2, y2 as -2, -1, x3, y3 as m, 0. If we substitute these values in that formula, then what happens? X into, in place of y2 we will have -1 and y3 means 0, that is nothing but -1 -0. Next one, x2 in the sense -2 times of y3 minus y1, that is 0 minus y, plus of x3 in the sense it is nothing but an m into y1 minus y2. y1 is nothing but y minus y2 means it becomes y plus 1. Now solve this equation and reduce this to simplest form to come across the line L2. That is nothing but cross multiply 2 to 0, then we will come across -6 minus into minus plus 2y plus my plus m, which is equal to 0. So if we make the coefficient of x as plus 1, then it becomes x minus of 2 plus m into y. Next, which is equal to m. Call this as equation 2. Here what we did, we took minus n as common. If we take minus n as common, the coefficients of m will be -1 and even y coefficient will be -2 times of, minus of 2 plus m. I am shifting this m to right side, then we will come across the equation as x minus 2 plus m into y, which is equal to m. This is second line equation. Okay. Now I am rewriting those 2 equations, that is nothing but x plus y, which is equal to 1 was first line equation, and second line equation was x minus of 2 plus m into y, which is equal to m. This was second line equation. Okay. Next, now I am going to tell you one of the important formula for one of the important condition for which lines to be perpendicular. That is nothing but, observe here, whenever any line equation is given in the form a1x plus b1y plus c1, which is equal to 0, and another line equation is given in the form a2x plus b2y then plus c2, which is equal to 0, means a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. If these 2 equations represent 2 lines, line 1 and line 2, we can say these 2 lines are perpendicular. Line 1, line 2. We can say these 2 lines are perpendicular if it satisfies condition. Condition is nothing but a1 a2 plus b1 b2 is equal to 0. This is the condition to be satisfied to say 2 lines are perpendicular. Okay. What about this a1 and a2, b1 b2? a1 acts as the coefficient of x and b1 acts as coefficient of y in line 1. a2 acts as coefficient of x, b2 acts as coefficient of y in line 2. Now we are going to make use of this formula to check the value of m for which lines to be perpendicular. Since Since, let me denote this as L1 and this one as L2. Since L1 is perpendicular to L2. L1 is perpendicular to L2. That means it has to satisfy condition. Condition is what? A1, A2 plus B1, B2 is equal to 0. Here value of A1 is coefficient of x in first line equation. That is nothing but 1. A2 in the sense coefficient of x in line 2, that is 1, plus of B1. B1 in the sense it is 1. Next minus 2 minus m. This is the coefficient of y in second line. We are equating this to 0. If we equate this to 0, then what happens? This one is nothing but 1. Bring the 1 to right side, that is minus 2 minus m, which is equal to minus 1. Better shift m to right side, then we come across m, which is equal to m minus 2 minus m, right? Okay. I am going to rewrite those two line equations. That is nothing but line L1 is denoted by x minus 2, which is equal to 1. All these are equation 1. And line L2, it is considered as x minus of 2 plus m into y, which is equal to m. All this as equation 2. Now thing is, we need to check for what value of m is line 1 is perpendicular to line L2. Since line 1 perpendicular to line L2. Here we do have one condition, that is nothing but, you observe this one. If line equations are in the form a1x plus b1y plus c1, which is equal to 0, and second line equation is in the form a2x plus b2y plus c2, which is equal to 0. If these are the two line equations, then we come across one condition for which lines to be perpendicular. Here lines are nothing but this one. This is L1 and this one is L2, which represent these two equations. Okay. We can say two lines are perpendicular if the satisfy condition. Condition is nothing but A1 A2 plus B1 B2 is equal to 0. If this condition is satisfied, then we can say that given two lines are perpendicular. What about A1 A2 B1 B2? A1 B1 are the coefficients of x and y in line A1, and A2 B2 are the coefficients of x and y in line 2. Now we are going to make use of same condition over here to find the value of m. That is nothing but n. Here A1 value is 1, B1 value is A1 value is 1, B1 value is minus 1, and A2 value is 1, B2 value is minus times of 2 plus m. Minus times of 2 plus m. Okay? Substitute those values over here, then it becomes A1 A2 in the sense 1 into 1 minus 1 into minus 2 minus m, which is equal to 0. Then it gives values as 1 minus 1 plus 2 plus m, which is equal to 0. That means m is equal to minus 3. Means it indicates that if m takes value as minus 3, then the line passing through these 2 points will be perpendicular to each other. So this is the procedure to crack this problem. Okay.